The refrigerants that are in use today in refrigerators are called super greenhouse gases, and that's because they have 1,000 times higher global warming potential as compared to carbon dioxide. If countries continue to develop the rate at which they are growing and people continue to expand and buy the refrigerators that way we expect them to, there are estimates by year 2050, refrigerants will be responsible for 40% of global warming. That will be 3 times more than the automotive exhaust at that time.
Sheetak is a startup founded in Austin, Texas. We have a singular focus to develop and commercialize efficient, affordable, solid-state energy converters for a variety of refrigeration, air conditioning, and power generation applications. We saw the funding announcement about the BTED program by ARPA-E. The central goal of the BTED program was to actually make efficient air conditioners for large building use, which would reduce the demands for power generation and at the same time eliminate the polluting refrigerants in these systems. To make a big difference, you have to look at alternative technologies. We have a technology which is completely electronic. It is light, it is non-polluting, it is very reliable because there are no moving parts. It's very low cost. It can be implemented with semiconductor manufacturing techniques in high volume, and so it has a lot of cost metrics and performance metrics that could enable a phase out of the traditional vapor compression engines.
This is a compact refrigerator unit that we have retrofitted with Sheetak technology. It does all the job that the original compact refrigerator was doing. The Sheetak engine itself is fitted at the back of the unit. The complete engine is replacing a much heavier compressor and the refrigeration system. It has about the same performance as the compressor, has the same energy efficiency, zero global warming potential, and it is significantly cheaper to begin with.
We had 3 major breakthroughs. We introduced new kinds of nanostructured materials which enhance the efficiency of these devices by almost a factor of 2. We managed these high heat fluxes. These heat fluxes are order of kilowatts per centimeter squared, the hottest chips in the market. We significantly lowered the cost of the system. The entire cooling device for the same cooling power is 10 times cheaper. The same materials can be used to have efficient power generators. In a lot of applications which are reciprocal, where you have heat available from low-cost sources, you can actually create a temperature difference, and that would produce electricity. There are all these specialized applications where our solid-state energy converters, although right now it's in the form of coolers, could be used in broader markets. Getting the ARPA-E's organizational support was very important. So there are a lot of OEMs that could be introduced to us through the efforts for commercializing our technology. The main core in traditional vapor compressor mechanical refrigerator industry are all being manufactured abroad, like in countries like China and Brazil. We offer a new paradigm which is based on semiconductor processing techniques which are more geared for US jobs. Austin is uniquely positioned because it's been a hub for semiconductor processing industries over the last 2 decades. We have the proper infrastructure to adapt these old processing plants. Our plan is to manufacture cooling engines in Austin, Texas and sell globally.